In this segment, we're going to go over Newton's 3 laws of motion. Let's start with Newton's first law. Newton's first law is a Roman numeral 1, and it says a body continues at rest or in uniform motion in a straight line unless acted upon by some force. So let's look at this first part. A body continues to be at rest. If you are a body, and this is you, and you are at rest, that means you're not moving, you're just standing there. If you are at rest, you will remain to be at rest unless something makes you move. So let's say nobody comes along and pushes you, you are just going to stand there. So if you are at rest, you will continue to remain at rest unless someone comes along and pushes you and makes you move. So a body at rest continues to be at rest unless acted upon by some force. Now let's look at the other part of the definition. Let's say a body is in uniform motion in a straight line. Well, let's say now that you are walking at a constant pace. So you are walking in a straight line in uniform motion. So the second part of Newton's first law says that you will continue going in a straight line in uniform motion unless acted upon by some force. Let's say you're looking at your cell phone and you're looking down and you're continuing to walk in a straight line and you're not paying attention to where you're going, and there's a wall in front of you, big tall wall, and you don't see it. Well, you will stop at the wall. You'll do a faceplant on the wall because you're not paying attention. The wall is the force that causes you to stop. So Newton's first law, the second part of the first law, says a body in uniform motion will continue to be moving in a straight line unless acted upon by some force. In this case, the wall prevented you from going forward. Let's look at Newton's second law. Newton's second law says that the change of motion of a body of mass is proportional to the force acting upon it and is in the direction of the force. So the change of motion is the letter A. A is acceleration, and acceleration is an increasing change of speed. So let's say you're at a red light and you're sitting there in your car at the red light and you got your foot on the brake. And then the light turns green and you step on the gas pedal. And you look at the speedometer and you see that the speedometer is changing. It's going from 0 miles per hour to 5 miles per hour to 10 miles per hour to 20 miles per hour to 30 miles per hour. So it's changing over time. It's increasing. So your speed is increasing. Your car is accelerating. So acceleration is an increasing change of speed. Let's go look at a body of mass m. So m is mass. It's the matter that makes up the object. It's the atoms and molecules combined that make up the object. Now let's look at force. A force is a push or a pull. In the grocery store, you can stand behind the grocery cart or buggy and push it, or you can stand in front of it and pull it as you select your groceries off the shelves. So a force is a push or a pull. So Newton's second law is telling us that the change of motion A of a body of mass m is proportional to the force acting on the body of mass m and is in the direction of the force. So I drew arrows above F and A. So if the force is to the right, the acceleration will be to the right. Let's look at an example. Let's look at a baseball player. He's carrying a baseball. The mass of the baseball is m. Now the baseball player throws the baseball of mass m to the right and causes the ball to accelerate. The baseball player is the one that's applying the force F to the ball, and it's to the right. The ball responds by accelerating out of his hand and increasing in speed to the right. The force applied by the baseball player to the mass of the ball causes the ball to accelerate. Otherwise, F equals ma. Let's look at Newton's third law. Newton's third law states, when one body exerts a force on a second body, the second body exerts an equal and opposite force back on the first body. And notice it's a Roman numeral 3 here for Newton's third law. So we put in an imaginary wall in red dashed lines between the two people, showing that the wall is not moving. It's staying stationary. So what Newton's third law says is when body A exerts a force on body B exerts an equivalent force back on body A. The two people are pushing equally on each other and no one is moving. Now what happens if body B wants to apply a big push to body A and get body A to fall over? Well, body B is then applying a force, and we no longer have Newton's third law. What we now have is Newton's second law. Body B is applying a force to body A, causing body A to fall over. So body B is enacting Newton's second law. Only when the forces are equal will we have Newton's third law, when both are pushing equally on each other, so no one is moving.